Hello, I hope you are all fine this week. Before a new lecture start, I would like to remind you about the assignment 2 that I have given to you yesterday. Please make sure to work on it and submit next week on Monday. So today we will start a new subject. It is a new challenging subject. It is about air quality and pollution. Today, it will be a kind of introductory lecture to give the historical overview of air pollution. I will discuss about global implications of air pollution and briefly, what are the global programs for air pollution control. When you look at the history, the Prometheus is a Greek titan that stole fire from gods and gave it to humanity. And the fire, symbol of progress and civilization. Fire also generates smoke, and it is one of the earliest anthropogenic air pollutants. Philosopher Seneca described the heavy air of Rome and the sting of the smoky chimneys thereof. There is one expression here which has been said. Luck is what happens when preparation meets opportunity. Actually, there is no real luck in life. There is only prepared people and prepared minds to receive that lucky moment. Queen Elizabeth, first one. London fogs become smoke, fall condition when smoke and fog intermingle. Queen moved to the Nottingham as she had allergy to coal smoke. So these are some of the, what happened in the past. And based on the irritation, she felt a law was passed prohibiting burning coal when Parliament was sitting. 1930s December, an inversion trapped smoke in Belgium, highly industrialized Meuse Valley. And 63 people died and several thousands others become ill in a week-long thermal inversion. I will explain what is the meaning of thermal inversion in the coming slides. But you can see when this happens, people might die and many people can be feeling ill. This is what happens in the normal situation. The hot air very near to ground, where the people live, where is the human activities, and the atmospheric layer when you go upper and upper, becoming cold. So the air can move easily from down to earth and diluted. But when the cold, which is thermal inversion, an inversion layer warmer than air, come and cover the previous layer of atmosphere. So that's why the pollutants cannot move further in the atmosphere, so they are accumulated where the human being lives. This is the reason pollution-related death and sickness might happen. I will also add additional video to teams about what is thermal inversion and why it caused and what are the effects. So please make sure you watch this short video. This will make your understanding much better. So this is how it looks when the temperature or thermal inversion happens. You can see the atmosphere is very polluted because any emissions have not been able to go over in the atmosphere and they are all accumulated very near to ground. 1948, Donora, Pennsylvania. Smoke-related coal burning for steel production and household heating led around 20 deaths and 14,000 illnesses. December 1952, which is called London smoke crisis. Up to 4,000 dead prematurely and 100,000 respiratory illness. and extremely dense smoke related to coal burning for heat and industry. You can see most of the things were related, use of heavy coal burning and industrial emissions during that time. Particulates and sulfur dioxide level rose due to extensive use of coal in heating and power production. People developed red eyes, burning throats, and nagging coughs. The elderly and the people with chronic respiratory problems were dying because they are the most sensitive groups. As you can see, even the coronavirus is hitting more seriously to the elderly people and the people they have chronic health problems. So based on all this, what happened, Britain passed Clean Air Act in 1956. Pea soup fog, also known as black fog or killer fog, is a very thick and often yellowish, greenish, or blackish smoke caused by air pollution that contains soot particles and the poisonous sulfur dioxide gas. This very thick smoke occurs in cities and they are derived from the smoke given off by burning of the soft coal for home heating or in the industrial processes. US government passed Air Pollution Control Act in 1955 and 1963 Clean Air Act has been also accepted. 1970 Clean Air Act gave the job of implementing regulations to newly established Environmental Protection Agency, EPA. We have spoke at the beginning of this course, and EPA is really one of the very well established institution regarding the environmental protection in US. What are the global implications of air pollution? If Earth is to remain inhabitable, we should not neglect the effects of pollution on atmosphere that blankets it. So where we live, where we breathe is really important, and we have to protect the air quality. So isolated examples give evidence of what can happen when any one community experiences heavy exposure to pollution for a long period of time. So you have seen some of the selected examples. It can be devastating if you expose to pollution for a long period of time or a community exposure to a pollution happens. And what about the global implications of various forms of air pollution? I will highlight a few of them during that lecture. When we look at the composition and structure of the atmosphere, you can see nitrogen and oxygen is the highest and the biggest portion of the atmosphere. The first column shows the concentration of these gases. Second column shows their presence as a volume. And nitrogen is occupying almost 78%, oxygen is around 21%. And the others, argon, carbon dioxide, methane, in the original situation they are really low. They are a very minor fraction of the natural atmosphere. I would like to also mention the structure of the atmosphere and what happens in different phases of the atmosphere. Troposphere is the first layer where the human being lives and most of the activities, man-made activities happens near to ground. And as you can see, when you go higher level in that phase, the temperature is becoming less. In the stratosphere, it is exactly different. When you go higher and higher, temperature increase. So you can see the layer of greatest interest in pollution is the troposphere, as has been shown in the previous slide, because this is the layer in which most living things exist. Human being, plants, animals, all the living things are here. So most of the things are, even the Mount Everest is less than the troposphere layer, and most of the activities, commercial jet and others, are also happening troposphere, up to 10 kilometers between ground and atmosphere. One of the biggest problems when there is air pollution is the acid rain. Acid rain is a rain or any other form of precipitation that is unusually acidic, meaning that it has elevated levels of hydrogen ions. That means having low pH. Acid rain can give harm to the plants, aquatic animals, and infrastructure. As we know, low pH is very hazardous and can give damage to the tissues and even the materials and infrastructures. Acid rain caused by emissions of sulfur dioxide and nitrogen oxide. These are the main two elements causing the acid rain, which will react in the water molecules in the atmosphere, and they produce the acids. You can see here some kind of diagram, at least to make you what are the sources of acid rain gases. You can see the SO2 and NOx is coming from different industrial sources and reaching the atmosphere. And sometimes these gases reach to receptors, to the ground, to the plants, to the forest in the form of wet deposition. In the gas phase, sulfur dioxide is oxidized by reaction with the hydroxyl radical via an intermolecular reaction. You see the reactions happening on the screen. And in the presence of water, sulfur trioxide, SO3, will be converted rapidly to the sulfuric acid. Hydrogen 2 and SO4 is the form of sulfuric acid. And usually, as you know, they are one of the strong acids. Nitrogen dioxide also reacts with hydroxyl group to form nitric acid. And the equation also has been shown on the slide. You take your time, look at the equations, and make your mind how these acids are formed in the atmosphere. I added some photos here just to show how acid rain can affect the forest. You can see the forest, all the leaves have been dyed because of acidic rain. The acidity, very low acidity, can really affect badly ecosystems. And you can see also here another photo, protection of statues in Harvard University from acid rain. They put some kind of protective cover on the statue because they don't want this statue's material to be degraded because of acid rain. And we mentioned now about the acid rain, and another issue, main issue, is ozone depletion, what is going on recently. And you can see here ozone concentration, estimated ozone concentration on the world. How the ozone depletion happens? One of the reasons is the use of chlorofluorocarbon materials. And this UV energy removes the chlorine from the chlorofluorocarbon molecule, and chlorine become released and becoming active, and chlorine radical breaks the bond in ozone molecule. This is how atmospheric chemistry works. Any free chlorine coming from the chlorofluorocarbon molecules can break the ozone molecules, and which is called ozone depletion. Ozone layer is a protective layer around the atmosphere, and it has so many depletion of ozone, has so many negative impacts. So it needs to be protected. That's why some governments utilize or applies some legislation which is prohibiting or avoiding the use of chlorofluorocarbon molecules. One of the other main subject is the climate change. This was about your assignment 1, and thank you very much. Everybody has been done really great assignment and learned new things. And we know it is a well-known fact that atmospheric carbon dioxide increased caused the temperature, global increased temperatures. So as you can see here in the photo, the trend is increasing temperature, and recently this increase even become sharper. So global climate change is also one of the main important issue we need to take care. And lastly, this is last slide. I would like to tell briefly some of the global programs for pollution control. WHO, World Health Organization, WHMO, World Meteorological Organization, initiated air monitoring program. These are some of the international programs dealing with the air pollution control. UNEP, United Nations Environmental Programme, also authorized implementation of global environmental monitoring system. And typically, monthly means of SO2 has been found around 20 to 100 microgram per meter cube on urban scale. This is as a reference from World Health Organization. 10 to 40 on continental scale, and less than 5 on global scale. So these are some of findings of global programs. I hope you have been introduced now what is going on related with air quality, and in the next lectures we will go into more detail. Have a very good week.